OD is linear or not. That's because if it's a linear, we have a very powerful formula. We can just apply the formula and we'll get the solution immediately. Okay, so let's say we have a linear ODE. Okay, this powerful formula, you can immediately get the solution. You can immediately get the solution. And here's the formula, right? The formula is first thing, let's create something called the integrating factor. Okay, it will be a function of x. So what is this integrating factor? It's e to the power of the integration of px. Okay, it's just, all right, here you have px, then you just need to integrate px and e to the power of that. So e to the power of that, one thing, when you get the answer, you don't have to plus c here. Okay, not like the regular indefinite integration, you don't have to do the plus c here. Okay, just leave it. If the integration is just x, just leave it as x. If it's x squared, just leave it as x squared. Don't do the plus c here. Okay, and after you get this integrating factor, then the answer is very, very simple. You can just apply this formula. So the answer will be the integration of the right-hand side qx times this integrating factor ix, right, divided by the integrating factor ix. Okay, that would be the result of y. Okay, so if it's a linear ODE, then you can apply the formula, you can immediately, get the result. Okay, you can immediately get the result. So here's an example. Question 3, there are examples. So again, the first thing you have to determine whether this ODE is linear or not, right? Just like what you did in problem 2. So this part, it is linear because here plus 2 is my px. Right? Even if it's a constant, you can treat it as a function of x. It's a constant function. Then the right-hand side is 2e to the power of x. It's my qx. Right? Then to apply this, okay, then it is linear. So I can use my formula here, right? So I can use my formula here. So to use your formula, you just need to get ix. Right? What is ix? Ix is e to the power of the integration of px. Here my px is 2. So just do this. Okay, then you integrate 2, you will get 2x. So you don't need to plus c here. Okay, that's unnecessary. Only for this specific case. Okay, only when you're getting the integrating factor, you don't have to plus c. So this is your ix. Okay, then apply the formula, you will get the answer. So you just need to integrate qx, this part is your qx, times ix. Right, what is your ix? Your ix is e to the power of 2x. Okay, you integrate this side over ix over e to the power of 2x. Right. So that's all you need to do. And just finish the calculations. 2, you integrate e to the power of 3x dx, right? And divided by e to the power of 2x, right? So you multiply it with e to the power of negative 2x. Then this integration, okay, this integration, you have to do it with c. So it's 2 e to the power of negative 3x times like 1 over 3 e to the power of 3x. Okay, plus c. Okay, then this part is 2 over 3. Wait, here's a typo. Right? Copy is just negative 2x. Here's 2 over 3 e to the power of x plus 2c e to the power of negative 2x. Okay. So you can see it's very convenient, this formula. As long as the OD is linear, you can immediately apply this formula and just do an integration, you'll get the answer. Okay. But of course, first you have to make sure the ODE is linear before you do this. So the second question, x times y's derivative minus 2y is x squared. Okay, again, first you have to change it to the form y derivative plus pxy is equal to qx. Okay, first you have to change this ODE to this form before you do all the integrating factor thing. Right? So divide x on both parts. Right? Then this part is of px. Okay, this part is your qx. Then it is linear, so you can just apply the formula. So to get the answer, you first need to get the integrating factor, right? Which is e to the power of, you integrate negative 2 over x dx. So here, if you integrate it, there will be e to the power of negative 2 lowering absolute value of x. Okay? Because if you integrate the negative 2, you can put it in front. And 1 over x, the integral is lowering absolute value of x. Then e to the power of lowering absolute value of x, right? And then to the power of negative 2. So e to the power of lowering anything, it will just be absolute values power of to the power of negative 2. Right? So it's just 1 over the square. So it's just 1 over x squared. Okay? It'll be just 1 over x squared. So that's ix. So to write down y, you just need to integrate qx times ix over ix. Okay? So here you just need to integrate qx, it's x, right, times ix is 1 over x squared dx over ix, right, over 1 over x squared. Okay, so that's what you get, and you integrate 1 over x, again, you have lowering absolute value of x, okay, plus c. So this will be your answer. Okay. Then last question, it's the same. It's a okay, but last question, you have an initial condition. So later we'll use this to get c, get the value of c. Okay, again, this is linear. This part is your px. This part is your qx. So first part, what is ix? Ix, you integrate negative 2x dx. Right, so it will be just e to the power of negative x squared. Right, then y, it's going to be integrate qx times ix over ix. Right, so qx, copy it down. Ix is e to the power of negative x squared and over e to the power of negative x squared. Okay, so here at the top, you can see these two parts. The product is 1. So you just need to integrate 3x squared. And then the bottom, right, you divide by e to the power of negative x squared. It's just like you multiply e to the power of positive x squared. Okay, then it's e to the power of x squared times x cubed plus c. Right. Do you have any questions for this part? Okay, the last part, just apply the initial, just use this initial condition, right? When x is 0, y is 5. Just use this piece of initial condition to get the value of c, right? Which means when x is 0, y is 5. So this is it. So C is 5. Okay, so your answer is y is equal to e to the power of x squared, x cubed plus 5.